Hi everyone and Assalamualaikum. So today we are from Group 4 and we are going to present our group assignment project for our DIY air conditioner. So here is our group members. Here is our agenda starting from first common aircon, next DIY aircon that we found, and then some calculation and comparison. For common air conditioner, we choose Media Extreme Dura R32 aircon as our reference for common air conditioner. So basically, the main highlight here is all about it use R32 refrigerants. It use power consumption about 3000 watt and energy usage about 9706 kilojoule. So for our common air conditioner, basically it just a revision for what we have learned before. It consists of compressor, condenser, evaporator. So for compressor, as what we have learned, here is where the work in is all about. And then we have condenser there, which is to release the heat outside. We have fan to increase the efficiency for the condenser to dissipate heat outside. We have evaporator, and then we also have blower, filter, and thermostat to control or regulate the amount of cool air.
So I'm going to present about the details of DIY air conditioner. First, for the materials needed, there are fan with adjustable speed to control airflow and cooling effect, the cooler box to hold ice, then the insulation material which is to minimize heat exchange, and the most important material, ice as a cooling medium. So this is the design of our DIY air conditioner. For the working mechanism of this DIY air conditioner, the first process is the fan inside the container draws warm air from the surrounding environment, which is the room, into the container. Then it comes into contact with the ice, which is the cooling medium. The heat from the air causes the ice to melt. During the melting process, the heat from the warm air is absorbed by the ice or water molecules, which cools the air. The now cool air exits the container through the insulated air duct and is directed into the surrounding environment. To achieve thermal equilibrium, the temperature of the room decreases. Finally, the cooling effect is achieved.
Our DIY aircon relates to thermodynamic principle. The ice from the box will absorb the heat and melts to achieve the thermal equilibrium with the warm air in the room. And therefore, the room temperature drops as being cooled by the cool air released from the ice. For the first law, the electrical energy is being converted to the kinetic energies from the blowing fan into the heat energy in the ice. The energy is not being destroyed but is being converted. So this is the comparisons in between common aircon and also the DIY aircon. And we are looking into four aspects: installation costs, electricity consumptions, monthly operating costs, and also coefficients of performance. Installation cost refers to the price of aircon or the material cost to build it, and DIY aircon having a lower cost as compared to the common one. The electricity consumption is the amounts of electricity used to cool the rooms, and the aircon only operates one time per day. DIY aircon having a 98.7% reductions in electricity consumption, which supposedly leads to a lower monthly operating cost. However, as the ice has to replace day by day, it leads to higher monthly operating costs in DIY aircon as compared to common one. DIY aircon having a better coefficient of performance as compared to common aircon. This means that DIY aircon has a higher effectiveness to remove the heat from the rooms as compared to common aircon. Here is having one remark. The number of months until the total cost of DIY aircon exceeds common aircons is around 10 months.
For the calculations involving DIY air conditioner, we first assume isobaric and adiabatic cooling of air. After finding the density of air and specific heat capacity at constant pressure, 27 degrees Celsius, we find the volume of air that needs to be cooled, and then the later heat of fusion of water. Next, we find the amount of heat that needs to be removed by the air conditioner, and from there, the amount of ice that needs to be supplied. And then we find the time required to cool the whole room, which is 103.56 seconds. After finding the individual component prices of the DIY air conditioner, we added them together to get a final installation cost of 109.35 ringgit Malaysia. To find the monthly operating cost of the DIY aircon, we find the total mass of ice and total electricity consumption inside 30 days, and then we find the cost of ice and electricity respectively. We then added them together to obtain the monthly operating cost. For the calculations involving the commercial air conditioner, we find the total electricity consumption and the cost of electricity using the same operating periods of 403.56 seconds per day for 1 month. Next, we find the number of months until the total cost of the aircon exceeds the common aircon, which is approximately 10 months. Next, the coefficient of performance of the DIY version of the aircon will be 227.96.
This is our reference. And that's all from us. Thank you.